Hi, my name's John Joseph, and this is the third video in my tutorial series on my procedural text generation tool, ProcGenie. In the first video in this series, we introduced the conceptual idea of a walker or a crawler as a traverser on a graph. So after we define start symbols, which we discussed in the last video, where does the generator go next? How is that decision made? We derive the term walker from the context of dungeon crawlers and believe that a dungeon crawler is a useful analogy for the ProcGenie procedural text generation process. In a dungeon crawler, an avatar traverses a dungeon, picking up items, deciding between branching hallways, encountering locked doors, finding keys, opening those doors, and proceeding. Similarly, in the case of ProcGenie, each time the generator, or the walker as we'll call it, moves to a new cell in the graph, it processes the text of a component on that cell before determining whether production rules, probabilities, and constraints would allow it to move to another cell. Processing that text can include many things: checking constraints, choosing between several available components defined in a single cell, running any defined processes on a selected component, dropping out of the selected graph into a different graph before returning to that graph, adding text to a running buffer of generating text, adding hyperlinks or choices, and even changing the world state or model. Rules, or directional rules, production rules, provide direction on possible generation spaces, and they serve like corridor branches in a dungeon crawler. At a branch, the generator could go left or right. If it goes left, it'll arrive at one result. If it goes right, it might arrive at another result. There are certain locks and keys, like tags or variables, that would allow or block movement to the next cell. After processing the text in a single cell, the walker will determine, or the generator, walker as we call it, will determine whether any additional rules have been defined that would allow it to move to another cell. The next cell could be an adjacent cell. So, as we saw in the first video, hello world can go up, and we could say, how are you? Right? So here you have a cell with a directional rule, a start symbol, and a directional rule. The directional rule says that you can go east. Hello world is a component in that cell, and a directional rule attached to that component says you can go north to how are you. So those directional rules, they instruct the walker on where it can go next. It could also be a cell in a different graph, and later on in the series we'll talk about moving between graphs. Or it could be a cell defined just by its coordinates. So you could move from hello world and you could move across the graph all the way over here. And that's a function that we call teleportation. We'll get back to that later. It's a fanciful term for it. If it can keep moving, the walker moves on to another cell to accumulate more text. If it's unable to keep moving, the walker stops and that generation run is over. So here you see, after moving here, there's nothing else it can do, right? There's no directional rules, no other rules that are telling the walker that it can go anywhere else, and so it stops. How are you? And that's where the generation ends. With that conceptual framework in mind, we'll use the word walker throughout this series to refer to the current traversing state and location of the ProcGenie generator on a graph. So we could say that the walker moves to this cell, that the walker picks up text, that the directional rule instructs the walker where it can go next, and that the walker runs out of places to go here. But let's look at directional rules as production rules in more detail. The path of the walker across the graph is defined in its simplest forms by the directional rules that are listed either as cardinal directions or as U for up on the z-axis, D for down on the z-axis. And that's just movement on the x, y, and z-axis of the graph. The syntax for these directional rules is to place the directional rule or rules within brackets. For example, let's start a new one here. Create a graph, and we'll move in. And let's say that we wanted to have a single directional rule. So start, and we can go one direction. We'll go down, so we'll go y minus 1 or south. And we'll say hello. But then we could also define multi-directional rules by including any number of directions separated by commas within brackets. So here we could do W, we'll go every direction except the starting direction. And then we could just add other text. So friends, people, cool cats, everyone, classmates, co-workers, and we'll say chickens. Hello, chickens. All right, so the start symbol defines where the start is on the graph. The directional rule S says that the walker can move y minus 1 from that cell to hello. And there's a directional rule attached to that component that states that the walker can move basically in any direction from that cell. There are no directional rules or productional rules that are attached to any of the cells to which the walker can go, so when we hit run, hello chickens, and that's the end of generation. Now, let's look back and let's add the two directional rules that we haven't talked much about yet, the U and D directional rule. Again, we talked about this in the first video in the series, but the down and up arrows will go up and down on the z-axis. So we could say, hello down there, if you go down on the z-axis, hello up there, if you go up on the z-axis. Now let's see if we can get those to run. Hello everyone, hello chickens, friends, classmates, hello down there, hello down there, hello coworkers. You're seeing just the massive amounts of combinations you can get very quickly with ProcGenie, but hello up there. So hello down there, hello up there. So at this point, just by directional rules, we have now added basically 9 different options. They can go 7 different cells on this part of the z-axis, or they can go up or down 1 or 2. And those are directional rules in a nutshell. They're just production rules that instruct a cell where the walker in a cell where it can go next. And without production rules, if there's nowhere left for the walker to go, then generation ends, and that's the end of your generated text.